Welcome to the continuation of the tutorial on quadratic sequence. So we are to find the next two terms and determine an equation for the nth term of this sequence: 5, 12, 23, 38. So for a start, we can't tell whether it is AP, GP, or quadratic unless we find their common ratios or common difference. So the difference between 12 and 5 will be 7. The difference here will be 11. The difference here will be 15. So you can see we are not having common difference. What about the common ratio? 12 divided by this will remain the same. 23 divided by this will also remain the same. So GP is out of the way. So we need to find the successive difference between the terms, whether we can generate a quadratic sequence. So let's rewrite the point. We have 5, 12, 23, 38. We are looking for the next two, so let's leave that and see. So in finding the common difference, we can see that between 12 and 5, we get 7. Between 12 and 23, the difference is going to be 11, right? If I add 11 to this, I will give rise to this. Okay. Then let's see the difference here. If you subtract this from this, you'll be having 15, meaning 15 plus this give rise to this. So the number we are looking for here plus a certain number. If I add a number here to this, I get this. The same way, if I add whatever I have here to this, you get this. This to this, you get that. So let's see. The difference are not the same. So we find the next common difference between 7 and 4. And that will be 7 and 11. That will be 4. Between 11 and 14 will also be 4. So since the difference here is the same, it means here will also be 4. Therefore, 4 plus this will give rise to 19. 19 plus this will give rise to 23. Therefore, the next two terms we are looking for is that this and this must be added to give us the next term. So we have 40, 57. So we have 57 as the next term. 57 will also be added to by 23 to give us the next one. I believe that will be 70 and 80. So therefore, the sequence, the next two terms will be 57 and 80. Meaning if we want to continue this sequence, looking at how the difference, the first difference will always give you AP, which is what arithmetic sequence. Then you have your common difference. All right. Now, in order to generate the formula for the nth term, we mentioned that the second common difference is always equals to 2a, where a here stands for the first coefficient of the n squared. We know from Tn equals to an squared plus bn plus c. This is the general equation we are looking for. Then the a here is what we are referring to. So we can say that 2a is equals to the second common difference, which is common. Therefore, it becomes 4. And we know if you divide both sides by 2, you have your a to be equals to 2. So a is 2. That's the first coefficient is going to be 2. All right. Now, we can also say that when n is 1, that is the first term. What is the first term? 5. So when n is 1, the first term is 5. Therefore, in place of n, I put in 1. That simply means that T1 will be equals to A times 1 square. So plus B1 plus C. What happened here is that since it is 1, all the variables will maintain a single coefficient or 1 as a coefficient. So here, okay, let's maintain it and have this as term 1 being 5 equals to A plus B plus C from here. And we know our A already is 2. So I indicate here with 2. When we come, we have B equals to 5 minus 2. That will be 3. Okay, B plus C equals to 3. So that's the first equation. I said in the previous episode that you can just go ahead and write your T1 equals to A plus B plus C. The T2 will always be 4A plus 2B plus C. Always. When you change this n to 2, you always get the same value in every question. So we can also say that when n is equals to 2, your T2 will be equals to 4A plus 2B plus C, as in changing the n square, which is 2 square, becoming 4, changing the n, becoming 2. And the second term from the sequence is 12. So 12 is equals to 2A. And what is our A? 2. And 4A. So A is going to be 2, giving rise to 8 plus 2B plus C. And this can also come here. Therefore, we are left with 2B plus C equals to 8 from 12 will give us 4. Equation 2. So we'll be solving the first two equations simultaneously in order to arrive at our general term. So solving these two equations, we can see that the coefficient of CC are the same. So I'll go for elimination. So we can have equation 2 minus equation 1, meaning 2B minus B. I'll be left with B. C minus C will be 0. Therefore, I'm going for 4 minus 2. And that will give rise to 2, meaning B is 2. So that can be put into any of the equations. Oh, no. This is 3 and 4. So it's supposed to be 1. So this is 1. So put B equals 1 into equation 1. Where is it? Here. Meaning 1 plus C equals to 3. C equals to 2. Meaning this minus this. Or better still, 3 minus 1 equals to 2. Don't forget, we know the A. We know the B. We know the C. So therefore, the general term is going to be A. What is our A? 2. Then the n squared plus B, which is 1 times n, plus C, which we found as what? 2. So this is the general term of the sequence or formula, which is used to find the nth term of this sequence. We can try and see if this is the first we are having here. If I put in 1, that's the first term. 1 here will be 2, 1 square plus 1 plus 2. This will be 2 plus 1 plus 2, 5. If I put in 2, it will be 2. Okay, let me use this here. 2, 2. So this becomes 2 times 2, 4. Times this will be 8 plus 2 plus 2. You give rise to this. So this is the general form that gives rise to the sequence that we have. So in some cases, you can ignore finding the two terms, get your general term, and find out 1, 2, 3, 4, 5. The fifth term, what will it give you? If you are looking for the fifth term, that means 2, 5 squared plus 5 plus 2. This will be 25. Times this will be 50 plus 5 plus 2, 57. The same way you will get this if we were to find a fifth term using the general rule. Alright, thank you for watching. like, share, and comment. Bye bye.